So in this video, we're going to continue talking about how to solve exponential equations. So remember, we have this property of equality for exponential equations. If a to the x equals a to the y, that means that x equals y. So when we solve exponential equations, we're always going to start off by rewriting the problem so that the bases are the same. Remember, you can use the squares and powers charts to help with this. Then you simplify the power of a power by multiplying the exponents together. Once the bases are the same, you can set the exponents equal to each other and then solve for the variable. So when you're solving exponential equations, remember sometimes you need to rewrite it to make the bases the same. So remember to use the squares chart and the powers charts so that they can help you out in seeing how to rewrite the problem so the bases will be the same. So remember also we need the power of a power property, which tells us that if a term with an exponent is raised to another exponent, then you have to multiply the two exponents together. Remember, we also have rational exponents, which may be rewritten as radicals. So if you have x to the m over n, that means that we can rewrite that as the nth root of x to the m. So let's try solving this problem. We have 1 over 8 to the x plus 1 equals 2 to the x minus 4. So if I look at the powers chart, I notice that 2 and 8 are both powers of 2. So I'm going to work on rewriting this. So this 1 over 8 I can rewrite as 1 over 2 cubed. Right? So that's 1 over 2 cubed to the x plus 1, and that equals 2 to the x minus 4. So 1 over 2 cubed, remember I can use that reciprocal property, so a to the negative m, 1 over a to the m equals a to the negative m. So if we rewrite that, that's going to be 2 to the negative 3 to the x plus 1 equals 2 to the x minus 4. So what we're going to do on the left side is now we have a power of a power, right? We have that a to the m raised to the n power, and that's going to be a to the m times n. So that negative 3 and x plus 1, we're going to multiply them together. So when we multiply those, we get negative 3x minus 3. So when we do that, we're going to get 2 to the negative 3x minus 3 equals 2 to the x minus 4. Okay, so now that we have the same base, we're going to set the exponents equal to each other and solve for the variable x. So we have negative 3x minus 3 equals x minus 4. So what we're going to do is to solve this is we're going to subtract x from both sides so we can move all our variables to one side. So we have negative 4x minus 3 equals, and then here x and minus x cancel, so we have negative 4. And then we're going to work on solving this equation. So we have negative 4x minus 3 equals negative 4. And so now what we're going to do is we're going to add 3 to both sides. So we add 3 to both sides, and that gives us negative 4x equals negative 1. We divide both sides by negative 4, and that gives us x equals 1 over 4. So that is the answer to this equation, right? So if we plug in 1 over 4 for our exponent, we'll get it to where both sides are the same. So now let's try solving 4 to the x plus 4 equals 16 to the 2x minus 1. So you can look at the powers chart and notice that both of these are powers of 4 because 4 squared is 16. So we have 4 to the x plus 4 equals, and then 16 we're going to write that as 4 squared, and then we have 2x minus 1. So on the right side we're going to multiply those powers together, so we have 2 times 2x minus 1. So when we multiply them together, we get 2 times 2x, which is 4x, minus 2 times 1, which is 2. So we have 4 to the x plus 4 equals 4 to the 4x minus 2. Okay, so now we have same base, so we're going to set the exponents equal to each other. So we have x plus 4 equals 4x minus 2. Okay, so now we need to work on moving all the variables to one side. So we have positive 4x, so we're going to undo that by subtracting 4x from both sides. So when we do that on the left side, that x, remember, has a 1 in front of it. So we have 1x minus 4x, which is negative 3x, plus 4 equals, and then 4x and minus 4x cancel, so that equals negative 2. And now we're going to subtract 4 from both sides. So when we do that, we get negative 3x equals negative 6. And now we divide both sides by negative 3, which gives us x equals 2. So that is the value of the variable that will make both sides of this equation equal to each other. So now let's go ahead and solve this problem. So in this one, we need to rewrite everything as a power. So we have an 81 and a 243. So you want to look around the powers chart and see which chart has both of these values together. So if we look at the powers of 3, you can see we have an 81 and we have a 243. So we're going to rewrite these in terms of powers of 3. So we have 3 to the 4th to the 3n plus 2 power over, and then 243 is going to be 3 to the 5th. So we have 3 to the 5th to the negative n power. That equals 81, which is 3 to the 4th. So now we need to simplify this left side. Okay, so when we multiply those exponents, so we have 4 times 3n plus 2. So we're going to distribute that 4. 4 times 3n is 12n, plus 4 times 2 is 8. So we have 3 to the 12n plus 8 over, and then 5 times negative n, that's going to be 3 to the negative 5n. So that equals 3 to the 4th. So now we can use that quotient property, right? If we have a to the m divided by a to the n, that equals a to the m minus n. So we can combine those exponents. We have 3 to the 12n plus 8 minus negative 5n. Okay, that minus negative will become a plus. So that equals 3 to the 4th. Okay, so when we combine those like terms, we can combine that 12n and that 5n. So that tells us that we have 3 to the 17n plus 8 equals 3 to the 4th. Okay, so now we need to work on solving that. 3 to the 17n plus 8 equals 3 to the 4th. So we have same base, so now we can set those exponents equal to each other. So we have 17n plus 8 equals 4. So we're going to subtract 8 from both sides. And when we do that, we get 17n equals 4 minus 8, which is negative 4. So we're going to divide both sides by 17. And when we do that, we get n equals negative 4 over 17. So that is the value of the variable that will make this equation true. So now you can go ahead and pause the video and try this example on your own. So in this problem, we have 9 and we have 27. So notice that these are both powers of 3. So we're going to rewrite the 9 as 3 squared, and we rewrite the 27 as 3 cubed. So 3 squared to the negative 3x is 3 to the negative 6x. And then 3 squared to the x is going to be 3 to the 2x. So that equals 3 to the 3rd. So when you're multiplying, remember you add the exponents. So we have negative 6x plus 2x, which is negative 4x. So we have 3 to the negative 4x equals 3 cubed. So we have negative 4x equals 3. So what we're going to do is divide both sides by negative 4, so we get x equals negative 3 over 4. So remember, you can solve an exponential equation using the property of equality that says that a to the x equals a to the y if and only if x equals y. So to use this property, you have to make sure that the bases are the same. Use the powers chart to change the values in the equation so that the bases become the same, and then you can use this property to solve.